Chapter 4, Tools. We are in a post-ERP world. We just haven't accepted it yet. Quote, "We are waiting for big ERP," unquote. CPG company. Quote, "It's a train wreck. They, each business unit, are using different legacy big ERP systems and platforms that are not integrated. People need to manually extract and input data, resulting in data accuracy issues," unquote. Energy company. When it comes to protecting the president, the tools employed by the U.S. Secret Service provide the active protective mechanism. But these tools only work if they are the right tools for the job and the tools are actually being used. We wouldn't want the president to ride in an unarmored vehicle. Similarly, those charged with protecting the president should have personal protective tools. Unfortunately, as evidenced during the Reagan assassination attempt, oftentimes we have the tools, but we fail to use them. This brings us to the current state of supply chain systems, which rely almost exclusively on the biggest, most expensive tool around, the ERP. This is the equivalent of driving the president in an unarmored car protected by Secret Service agents with no body armor and no weapons. We have fit-for-purpose systems for sales and human resources, so why do we not have one for third parties? There is little question that we need a singular customer record. There's no question that we need a singular record for employees. So how do we not have a singular record for third parties? We have requisition to pay systems that are focused on paying third parties. We have a myriad of ERP systems that manage material planning and execution, and in some cases pay third parties. We severely lack a singular system that manages all the information surrounding a third party. This would include all the information about the supplier, locations, contacts, banking, etc., data exchange, demand forecasts, orders, changes, etc., and intelligence, risk, ESG, supply market, etc. Right now, the best we have is a record of when and where payment occurred and to whom. This is limiting because it assumes every third party will transact directly. It also puts the focus on the transaction and not the third-party entity. This forces us to look at third-party information management and data exchange backward, which is the result of legacy supply chain system development. The near monopolistic grip that the few big ERP providers wield chokes innovation and ensures companies stay focused on solving yesterday's problems instead of building for tomorrow's needs. What if we could start over? What if we could build a new supply chain system from scratch? What would a supply chain system built around data exchange with third parties look like? What if we didn't have to deal with legacy technical debt, 1990s architecture, and pre-information era designs? Without these constraints, we could build a fit-for-purpose supply chain architecture and ecosystem of tools with third parties at the center. This ecosystem would enable the creation of crucial intelligence, the desperately needed third-party data exchange, and the intelligence to empower our people to meet the challenges of operating a 21st century supply chain. The digital tipping point. When it comes to supply chain management systems, I argue we have hit the tipping point at which we can no longer solely buy off-the-shelf software. First, today's business environment is vastly different and infinitely more complicated than when big ERP debuted 30 or 40 years ago. Consider the continual acquisition, divestiture, and separation of big enterprises. Unsurprisingly, 97% of Apple's supply chain runs through third parties. Amazon, quaintly dubbed the Everything Store, is continually branching out into new business endeavors to make its operations simultaneously more complicated, efficient, and cost-effective. The company is running a 21st century supply chain design against competitors rooted in 20th century designs. In the process, they are continually putting competitive pressures on traditional stores such as Walmart, Target, Best Buy, and logistics companies like FedEx and DHL. Amazon has constructed many of its systems around a custom-built digital backbone. The wildly successful Amazon Web Services, AWS, originally built to power the Everything Store, grew from $3 billion in revenue in 2013 to more than $62 billion in 2021. Their platform as a service allows for dynamic, elastic in Amazon nomenclature, scaling of infrastructure, and ready access to the latest in analytics, machine learning, AI, and other such innovations, powering the most complicated supply chain in the world. More importantly, this has put Amazon and AWS at the forefront of the most revolutionary supply chain innovations in robotics, IoT data collection and management, and even satellite connectivity. This on top of acquiring their own air fleets and container ships. In late 2022, AWS announced a new supply chain offering which aims to push supply chain designs into vastly new realms. By comparison, simply buying an ERP system to run operations for a multinational enterprise in the era of disruptions seems anachronistic at best and derelict at worst. To amplify this point, most global enterprises carry significant technical debt in the way of tens or even hundreds of disparate ERP systems. These systems will never be integrated, and attempting to integrate them into a single instance is a fool's errand. ERP consolidation is the biggest game of whack-a-mole ever. Most of these consolidation initiatives last 6 to 8 years and never reach their destinations. Companies spend billions of dollars with systems integrators and big ERP providers to consolidate these ERP systems. Most efforts will never bear the promised fruit, and some end in spectacular failures and lawsuits. Consider the following very public ERP failures. National Grid, the New York utility company, attempted to replace one big ERP provider with another for its internal financial systems. The budget estimate was almost $400 million. A series of flaws, including dispersing wrong payments, resulted in the need to bring on almost 1,000 contractors to fix both the system and the business problems associated with this failure. The total cost of the project came in at almost $1 billion. German retailer Lidl suffered a complete failure of its big ERP platform and had to write off 500 million euros. The worst part is they had to revert to their previous system. DHL, the global logistics provider, had to write off 338 million euros and revert back to their legacy system when their big ERP implementation failed. There are two sides to every story and lots of blame to go around. Big ERP likes to point at the systems integrators blame big ERP, and both big ERP and the systems integrators blame the client. These high-profile stories of failure are not one-offs. There are many lawsuits that get settled out of court, and from my own experience, nearly every large enterprise I work with has a similar story. This is an open secret in the supply chain profession. Very few people would disagree with these statements about big ERP's inadequacies. The problem is, what's the alternative? Interestingly, there are even big ERP expert witnesses for hire that will write expert opinions and or testify in lawsuits. Regardless of why this keeps happening, if we're looking at write-offs of 500 million or more, perhaps we should be taking a closer look at what big ERP is actually giving us. There is a market for expert witnesses to testify in ERP implementation failures, then it's at least worth asking if there's a better way. History of the ERP. ERP systems are, in a word, old. They trace their origins to the inventory control systems from the 1960s. The next major evolution came in the 1980s with material requirements planning software, which was used to coordinate specifications, sourcing materials, manufacturing, and product delivery. In the 1990s, the ERP became the unifying integrator of marketing, finance, and operations into a single integrated platform. Those days seem so quaint compared to the massive chaos and complexity that confronts us today. Of course, this means that today's complicated supply chains run on software that was innovative in the 1990s. As I wrote in Trade Wars, Pandemics, and Chaos, quote, today, supply chains run on software that was designed in the late 1990s. ERPs were new and innovative before 2000, and they have yet to measurably change. Of course, business has changed dramatically in that time. Large enterprises, especially those that grow through acquisition, are far more complex than they used to be. Consumers expect more. Businesses need to operate more efficiently. There's greater government regulation, increased competition, and general supply disruptions, unquote. As supply chain leaders, designers, and professionals, we need a whole new generation of tools that take advantage of the latest technology developments, create end-to-end intelligence, empower human intelligence, and are built around integrations and interactions with third parties. It's not hard to imagine that the multi-million big ERP software deals and associated systems implementations upgrades will steadily decline. To be clear, this is not to say we need to rip and replace existing ERP systems, but rather to acknowledge that the future supply chain systems need to be more fluid and nimbler and not solely dependent on a singular one-size-fits-all big ERP provider. This is the crux of what it means to be digital. Given the uniqueness of how businesses operate today and the disruptions they face, future solutions will require some off-the-shelf components and bespoke applications while carrying over legacy technical debt loads. More specifically, enterprises will need to build and maintain some key parts of their supply chain infrastructure. The next generation supply chain platform. The reality is that billions upon billions have been invested in ERP systems, and many more hundreds of millions will be allocated in the upcoming years. This is a slow-moving ship that will take a long time to turn. However, the ubiquity of ERP systems does not mean they are in fact solving the problem they claim to fix. More importantly, ERP systems are not useful for the future supply chain. So ERPs will likely remain, but they will increasingly be sublimated to being a transactional system of record. Of course, this will leave some difficult questions about the ROI and failed business cases. And every big ERP investment today increases the technical debt ceiling. The next generation supply chain platform will be borderless, built to facilitate ubiquitous data transfer from every possible third party that needs to consume or share data with our supply chain systems. There are 6 core components to designing the next generation supply chain platform. 1. Cloud infrastructure. 2. Data foundation. 3. Functional capabilities. 4. Intelligence. 5. User experience. 6. Orchestration. Each of these foundational components is designed for multilateral enterprise data exchange. First and foremost, the platform must be built upon a cloud infrastructure. Today, the choices are Amazon Web Services, Microsoft Azure, or Google Cloud Platform. However, over time, this may change as new providers hit the market or companies create their own cloud. Regardless of which one, the cloud infrastructure needs to have vast and ever-growing capabilities that stay current with the latest infrastructure, the latest AI/analytics libraries, and extended technology capabilities. The data foundation is also essential. This includes all the data management and connections to the internal and external data sources, along with the requisite data governance, ESG, and risk enrichments. We must also account for the foundational supply chain capabilities: plan, source, make, deliver, reverse logistics, and quality. Short term, this is where legacy ERP systems will continue to serve a role as transactional systems of record. But over time, these will be replaced by bespoke solutions that simplify transactions. Next is the intelligence layer. This is where we will build our supply chain control tower, an amalgamation of data from all internal supply chain functional areas and external third parties to holistically model, operate, and respond to supply chain needs, opportunities, and disruptions. The last component will be the user experience and process orchestration layer. This is where we will provide a singular personalized user experience to every user and role that interacts with the system. Historically, users had to be grouped into predefined, pre-programmed groups. We can now use intelligence to give every user a custom experience based on who they are and what they do in the system. Closely tied with the user experience is process orchestration. Think of this as putting intelligent guardrails of what users can or cannot do in the system. These guardrails will be dynamic and make use of machine intelligence that interprets user intent, asks clarifying questions, and guides different outcomes versus hard prevention rules. Hard-coded prevention rules frustrate users. Process orchestration makes extensive use of no or low-code solutions. Sidebar: the end of process mapping. One very important digital innovation is the emergence of workflow orchestration systems. These tools interface and exchange data with downstream systems to provide a consistent user experience. The tools are no or low code, which means any business user can define a workflow through a very simple drag and drop interface without programming skills. For example, at the beginning of the week, we could create a new workflow for suppliers to self-service check on invoice statuses. Then on Tuesday, we could create a new workflow for contractors to requisition software licenses. Wednesday, we could create a workflow to pipe crude oil commodity pricing data and the pricing rates from our contract repository to our commodity manager for evaluation. These workflow orchestration tools stitch together the vast complexity of systems into a single, easy-to-operate interface for internal or external users accessing our systems. This can include multi-application task management, data collection, communication streams, and almost any other imaginable use case. Historically, this level of data collaboration was only possible through complicated ERP integration. But this was self-defeating because it made maintenance, system updates, and upgrades more complicated and in some cases impossible. Now with these new orchestration tools, work that took months or years can now be done in hours. What makes these systems even more powerful is they can incorporate sophisticated intelligence and increasingly generative AI to render the processes even more streamlined. Instead of predefining 10, 100, 1,000 rigid workflows, we can simply define the starting point, the end point, and the constraints. Then the system will respond to the user intelligently and dynamically. In the process, the user gets a fully personalized experience without supply chain managers having to manage and program vast complexity into their supply chain systems. A good example of this is the Netflix interface. Every user sees a unique personalized list of content based on their preferences, previous activity, and input. It would be silly for Netflix to offer a static set of predefined content to every user. Yet this is exactly what legacy supply chain systems do. Even worse, I have a client that spent millions, yes, millions of dollars to define every supply chain process from level 1 through level 5. The systems integrator was more than happy to charge the client to do all this definition. Sadly, all this effort was wasted because it's not necessary in the age of generative AI-based process orchestration systems. Are your digital transformations just ERP investments in disguise? I've had more than one client tell me their digital transformation was consolidating many ERP systems down to a single instance. Reducing system complexity is good, but let's not confuse that with transforming into a digital organization. Perhaps the most glaring reason digital transformations fail is that they over-index on the big bang technology investment. For example, new system implementation, existing consolidation/rationalization, cloud migration, and so forth. Similarly, most companies are good at the lift and shift of on-premise digital operations to Amazon Web Services, Microsoft Azure, Google Cloud Platform. But moving infrastructure to the cloud is only the first foundational step toward becoming a digital organization. The real work and opportunity of cloud migration is to evolve the legacy systems, in this case, big ERP, so that you take advantage of the powerful cloud platform capabilities. At the time of writing, August 2023, AWS touts more than 200 different services. A truly digital organization would break up the lifted and shifted ERP systems into smaller components that use the myriad platform services that these providers offer. However, just because you move your infrastructure to the cloud doesn't mean the business will suddenly start using the systems or that legacy ERP systems are even using the extensive cloud services. Most digital transformations fail to consider the business adequately, and too much focus on an idealized state can guarantee failure. This just gives people the opportunity to poke holes in everything. As expected, IT is also one of the biggest impediments because, by definition, digital transformation will disrupt what they have done historically. In many cases, they won't do anything unless challenged, which is why there is a shift underway from Chief Information Officer to Chief Digital Officer. IT, and by extension the CIO, will grind you down until you lose credibility and/or waste millions of dollars. This dynamic can clearly be seen in digital supply chain designs where IT overextends its influence to the detriment of the business. Not so ironically, as I was writing this chapter, I took a break to go to the local vegan coffee shop. Just as I was driving home, I received a call from a client who figured out that the ERP platform provider could not offer a pleasurable user experience for its sourcing managers. By chance, they found a provider who solves this problem, and they tried to bring them in. The IT group challenged them as if on cue by pointing to the ERP provider who claimed that they could do it. First off, why is IT inserting itself into discussions about topics they know little about? How do they know what sourcing managers need? Have they ever done the job in question? Second, of course the ERP platform salespeople will say they can do whatever it is that's asked of them. They are financially inclined to say yes to everything. My client said he was simply going to let the ERP solution get deployed, fail, and then in a year introduce the desired solution, all because he was tired of fighting IT. This highlights just how inept and wasteful IT can be when it comes to digitizing supply chains. Unless IT people have had specific training in supply chain design and operations, they have no business making decisions because they're either relying on the ERP software provider or talking with no knowledge. And supply chain leaders who accept this are putting a noose around their necks. The moment a disruption happens, that noose will tighten. IT, have they earned a seat at the table? Nearly every client I talk to tells me they are a insert big ERP brand shop. Their goal is to consolidate and streamline into a single provider, a singular place to go when something goes wrong. It's hard to argue with that logic. Of course, that logic only holds if the provider can fix the issue or add the feature in a timely way. This is where IT and big ERP stifle efficiency and introduce significant operational risk. If you're trying to become resilient to keep up with volatile supply and demand shocks, or you're trying to lock up strategic partnerships, you need timely insights. To get timely insights, you need real-time data and advanced analytical modeling. See Chapter 3, Intelligence. Clients tell me time and again how IT cannot give them these capabilities. The thinly veiled excuse is that big ERP has all the transactions, hence the data you need. Just tell them what you require and it can be put into a report. That backward logic would be funny if it wasn't so risky to the business. In an era where our lives are influenced so heavily by algorithms, the idea of building a report is silly. Do you want to make users manually search through thousands of data points in Excel or a dashboard to find outliers when simply pointing an analytical model at the data will do the same task in seconds? It's especially asinine given that there are many off-the-shelf solutions that do these tasks with ease. A whole ecosystem of supply chain analytics tools has cropped up to provide specific insights that create the aforementioned value. IT has two typical and utterly lazy responses to this. First, they say, again, quote, "We are a big ERP shop, so they need to integrate with our environment," unquote. Of course, with API, Application Programming Interface, infrastructure everywhere, this is becoming less and less of a legitimate excuse in the cloud era. Next, they will ask their big ERP account representative for ammunition to fend off whatever external provider is being considered. The telltale sign they have done this is that they will bring the big ERP software provider in to talk to the business and explain how it can or will be done in their existing system. Of course, this is a stall tactic, and when they come in, they will hear you out, and then they will say that they have that feature in a future release. This wastes valuable time and money and frustrates everyone else involved. If the IT group wants to be part of a supply chain system design and operation, they need to earn their seat at the table. The default assumption is that because they are IT, they have ownership of everything that is technology. But in the cloud era, should that be the default position? When the collection of and use of supply chain data creates opportunity and competitive advantage, having an authoritarian entity with no knowledge of the nuances of the supply chain operations at hand, serving as the decider seems anachronistic, if not derelict. Far too often, the IT group is allowed to veto a business decision. This is backwards. When IT pushes the wrong technology into a solution, the business leaders, especially supply chain, should be able to veto the IT decision. However, that is not to say IT groups don't have a role in a modern organization, though many question that. But they must prove they know about the supply chain without asking their big ERP sales rep for ammunition to use against the business. They should know the difference between reporting on a transaction and generating business insight. They should know the difference between OTIF, on time in full, and ATP, available to promise. They should know how and why managing supplier golden records is different than other golden records. And they should know the difference between supply chain planning and demand planning and the various inputs. If they can't answer these questions, they have no business making decisions or running your supply chain systems. The other major challenge, the CIO. The CIO role has declined steeply over the past couple decades. Specifically, over the past 30 years, the IT department has gone through a massive rationalization as a result of technological innovation. In the late 1990s, CIOs were C-suite royalty strutting around as if they owned the place. They held the keys, literally and figuratively, to all the systems and data processing as enterprises started to embrace digitalization. These systems were complex, expensive, and required significant intervention to operate. Companies housed their systems in corporate data centers staffed by armies of well-paid systems and network administrators, developers, and security experts. Purchasing new capacity required serious capital planning and timelines, as physical servers had to be ordered, shipped, and delivered. Then they needed to be installed in data centers, networked, and ready for use. The CIO's army of highly paid technical experts managed all of these systems at a rough estimate of 1 human to 10 servers. The emergence of cloud computing in the early 2010s completely gutted this structure as all these servers moved to the cloud, making the ratio 1 human to 100 servers. More recently, with the move to computer platforms and self-managing diagnosing systems, the ratio of IT humans to server is 1 to 35,000. This shift has left the CIO organization reeling. The changes described above are certainly material. However, there's an even bigger change that's impacted the CIO and IT. The fact that digital capabilities can no longer effectively be isolated into a single central department. Instead, they are increasingly located in the business. Joe Papard, writer for the Wall Street Journal, is more blunt. Quote, "Here's the sad fact. Having an IT department is exactly what will prevent companies from being innovative, agile, customer-focused, and digitally transformed," unquote. He goes on to dismantle the, quote, "partnership engagement model," unquote, by which the IT group is a partner to the business, an order taker to the business. The business provides its requirements to IT. They go away, source, build the solution, and deliver it to the business. Hey, procurement people, does this sound familiar? The problem is that the IT objectives are independent from the business. Papard points out another key flaw. IT expenditures are defined upfront in annual budgeting processes, which require business cases, specifications gathering, and estimates. Assuming budgets are approved, project plans and execution takes place over months and years. This is why going with big ERP is so attractive to CIOs. It meets their need to justify their existence based on the old way of working. But that way of working snaps like an elephant sitting on a tree branch in a world of disruptions. In the platform era, success with digital has no correlation to managing the IT stack, uptime, or even user satisfaction. Instead, success needs to be measured in how technology contributes to the ability of the enterprise to meet customer expectations while operating in an efficient and economically viable manner. The implication is twofold. Digital resources need to be embedded with the business where they have a direct contribution and vested interest in the success of the outcomes. Correspondingly, the business has to be vastly upskilled in its ability to understand and adopt all this technological innovation. Let's take HR as an example. The IT business partner approach has historically been to put in a human resource system, such as Oracle's PeopleSoft, a truly archaic piece of technology, or Workday, a less archaic and only slightly less painful HR system. But if you look at it from a business point of view, enterprises need human capital systems. Human capital management is a vastly different approach that requires more nimbleness as new techniques emerge. Correspondingly, human capital management requires the need for a core backbone platform that can integrate with a wide variety of point solutions that cover everything from recruiting to offboarding and all points in between. A hallmark of these systems is the need for greater intelligence. Human capital management systems need to be able to answer such questions as, why do 70% of new hires leave within 2 years, creating a negative ROI on recruiting costs? How do we increase organic recruiting? What would motivate an employee to work for a 100-year-old company? These questions can't be answered by legacy HR systems. Those rigid systems were built in a different century and meant to collect and manage basic employee information in a very linear manner. Instead, underpinning these systems is the need for deep third-party integration with potential candidates, recruiting systems, LinkedIn, job sites, HR systems, and even CRM systems, customer relationship management. In short, human capital management requires the platform approach. As most modern chief human resource officers have learned, those monolithic HR systems neither support nor reflect the reality of the current ways of working. There's now a constant reliance on outside contractors, crucial need for data collection from many external sources, a requirement to train employees outside learning management systems, and significantly more varied and complicated workflows. Big HR systems struggle with all of this complexity, which is why there's a huge explosion in HR tech as startups and newer platform players start to hit the market. Moreover, human capital management requires building bespoke intelligence that takes advantage of all this data. Chief HR officers, like chief supply chain officers, are holding out for a hero that will provide a platform for easy data exchange, internally and externally, and access to sophisticated data science libraries and a smart, customized-for-me interface. It's pretty obvious why I'm making this comparison, and I could have made it for other corporate functions. It's time for supply chain leaders to adopt a platform approach. The other key takeaway is that the CIO is not at the center of the digital universe. To punctuate this trend, Chris Howard, Chief of Research at Gartner, commented that, quote, of all the roles that we cover, the role of CIO is in the most flux now, unquote. For many years, and even still today, CIOs acted as a gatekeeper citing integration and security issues. But in the era of cloud platforms, democratized data, intelligence, and automation, there's much less that CIOs can control, and in many cases, they can't even keep up. Gartner cites the percentage of technologists hired directly by the business units is 41%. That is a staggering amount and means that almost 50% of the CIO's historical workforce now sits directly in the business. It's also important to highlight that we are in the era where people in the business have vastly more technical skills than ever before. Data management used to be the purview of the CIO, something they failed to deliver. Undeniably, we shouldn't be asking technical IT to make decisions about data governance. The business needs to take the data from its raw form and turn it into intelligence without IT involvement. For supply chain leaders, the problem with all this is that CIOs still have a death grip on supply chain systems. Otherwise, we wouldn't be suffering under the crushing weight of big ERP. To be fair to CIOs, big ERP is the only supplier set still inviting them on vacations and to golf outings. One thing is clear, anybody in supply chain today needs to be vastly more digitally and business savvy than previous generations. The significant rise in third-party management means supply chains need vastly more simple and agile systems. Good enough is no longer good enough. Letting CIOs, influenced by big ERP, dictate the path forward puts the enterprise at risk and will ultimately lead to disaster. Architecting new supply chain tools. Architecting new supply chain tools. My fundamental argument for this book and the supply chain profession is that we need a new architecture built around third-party management to decrease risk and improve operational benefits, efficiency, agility, savings, and so on. To achieve this, we need a completely new infrastructure, one that centers the third party and data exchange. To attain this, we need 5 interconnected rings of capability. The first ring contains the data foundation, user experience, and integration. The data foundation will house golden records for third parties. It should also either contain or be linked to material and product golden records and product design and engineering files. The user experience will be the single interface that gives the user the personalized view into our supply chain capabilities, the quote-unquote ChatGPT interface. This will be paired with process orchestration software that will allow us to define and manage workflows through our systems. The integration will take the form of an app store and/or middleware to manage the integration and communication between all the systems. The second layer is the cloud platform. These are all the infrastructure-related libraries and technologies that enable us to connect, secure, and interact with the myriad of third parties. By using cloud-native infrastructure, we are unencumbered by the limitations of proprietary software. The third layer is related enrichments, such as risk and ESG, coming from third-party solutions that we need to apply to all of our data. Think of this as a filter that enriches all third-party data as it passes through. The final outer ring contains all the functional capabilities of the traditional plan, source, make, deliver, and reverse logistics capabilities. Here you may choose to use a traditional transactional system like an ERP for multiple areas of functionality, or you may opt for newer and emerging startups for crucial capabilities such as planning. The key here is that data flows seamlessly from application to application in the outer ring, but it also flows seamlessly through the inner rings to make various connections to third parties. Most importantly, in Figure 12, you can see the various third parties that need to interact or transact with the enterprise. I cannot stress this capability enough because if you look at the next figure, you'll see that every third party has its own version of this circle diagram. This visualization is exactly where the complexity of transacting and data exchange with third parties really becomes apparent. If we go back to the vaccine example I posed at the beginning, you can start to see why it's so difficult. Every individual entity, whether vaccine manufacturer, ARC, rail provider, trucking company, warehouse, injection site, healthcare provider, insurance company, government, and possibly NGOs, needs to exchange data with one another. And they all use disparate systems, none of which natively talk to one another, while some systems do not integrate at all. By incentivizing and rewarding third parties to share their data and facilitating it seamlessly, we can close gaps of incomplete data, which in turn makes us more secure. The donut hole. The cloud revolution has changed the question of make versus buy. Now it's about make and buy. We've moved from the debate between single tool and best of breed to a platform with best of breed. The cloud revolution has changed the question of make versus buy. Now it's about make and buy. We've moved from the debate between single tool and best of breed to a platform with best of breed. This can best be described as a donut with frosting and sprinkles, the donut itself representing the platform and the icing and sprinkles representing the best of breed applications. That analogy works well because it shows that there's still a gap in the middle of the donut. I frequently get pigeonholed as advocating best of breed over traditional suite solutions. My response is always the same. I'm for a platform ecosystem approach that incorporates the best of both. However, even the platform approach is not fully sufficient as it does not account for the unique use cases of every industry and company. I call this the hole in the donut. The only way to fill this in is to develop internally or co-develop custom proprietary intelligence assets. In other words, to truly build the next generation supply chain platform, every company will need to assemble some measure of bespoke intelligence assets to fill the donut hole. This is not something an off-the-shelf provider can deliver because it will never meet their incentive structure. Every platform and best-of-breed solution will only make money if they can scale. The key to scaling is uniformity. This is not a criticism, it is a reality. This rightly puts the burden on filling the donut hole on the company itself. And this is exactly why having a strong digital capability is necessary. Track and trace as a donut hole example. Track and trace is an excellent articulation of the donut hole problem. A robust track and trace capability is the ultimate revenue risk management because it protects the brand. Track and trace does this by stitching together quality, compliance, efficiency, and customer experience through the use of data. The lowest threshold is to ensure quality standards are met for every product. However, for highly regulated products, quality must include requisite safety and counterfeit prevention. That means quality needs to be tracked, tested, and validated from the source material through the production to the delivery. Nearly every global enterprise has various local, national, and global regulatory compliance responsibilities. These requirements manifest themselves in the supply chain where every step needs to be validated to ensure that all activities in the execution meet internal, corporate, and legal compliance. Once again, technology and data capture with third parties is key throughout the process. Ultimately, the customer wants the product or service when it is promised. It's no secret that the advent of same-day, 2-hour delivery and the like have created absurd expectations. Achieving this, assuming that remains the goal, requires significant end-to-end information transparency at each step of the production and distribution process. This enables significantly more robust and timely information sharing to the end customer. Going back to the vaccine example, I wanted to pull the track and trace data for the vaccine I had put into my body. That should be readily available by scanning the QR code on a vaccine card, or ideally directly connected to my electronic medical record sitting in the digital wallet on my iPhone. Having track and trace information plumbed into customer-facing order systems allows us to give customers greater visibility into the supply chain that produced and delivered that product. The reverse is also true, but if we reverse the data flow from the customer, we can use it to forecast future demand, engage in preventative maintenance, and eventually reverse logistics for the reuse or reincorporation of that product at its end of life. Trying to hit all of these objectives, not even accounting for disruptions or just day-to-day friction, requires continuous improvement of the underlying platform services. In other words, there will never be an off-the-shelf type solution. As with any operational data, track and trace data can inform continuous cost and efficiency improvements and complexity reductions. I know what you're thinking. We do this in lean manufacturing already. That is good. And this is not meant to replace that, but rather to point out when you have many third parties involved in manufacturing, packaging, and distribution, the track and trace data collection and interpretation becomes an exponential problem. Going back to the vaccine example, we can start to connect all these dots. As a customer, I wanted to know if all the entities that handled the vaccine met quality, safety, and regulatory compliance standards. As a customer, none of this track and trace was available to me. If there was a recall, how would that information have made it from the manufacturer to me? Moreover, had I experienced side effects, how could I have let Moderna, the medical profession, or regulators know? The data provides me with that chain of custody. When Tony Soprano eats the donut, the limitation of digital track and trace. Track and trace technology has simultaneously both evolved and not evolved much over the past few decades. For many decades, we have used Uniform Device Identification, UDI, Global Data Synchronization Network, GDSN, and barcodes to keep tabs on our supply chain operations. In the early 2000s, innovations such as radio frequency ID, RFID, real-time locating systems, and beacons, Bluetooth transmitters that send signals to nearby devices, hit the market, providing basic tracking and real-time identification and location-based trigger alerts. Increasingly, we are moving to more smart device sensors communicating to the cloud using IoT, digital ledger technology, AI, near-field communication, and drones. Automated signal processing and intelligence creation hold the promise for auto-capturing, processing, analyzing, and syndicating the requisite information to any system of consumption. This can include triggering smart contracts or complete transaction records such as change control, chain of custody, or signed-off validation. However, there is a lot of hype about using this digital ledger technology, also known as blockchain, for track and trace. Conceptually, blockchain is an immutable digital ledger to track every step of the track and trace process. And that's great. But it's important to understand that DLT is completely virtual, so that you need to connect it to a physical internet-connected device. And these devices need to embed into a container, pallet, or other such fixed place with the source material. However, most raw materials, such as liquids, agricultural products, textiles, and other inanimate objects, do not lend themselves to having physical devices connected to them. So we must put the devices on the holding/packaging containers themselves. This leads to the Tony Soprano problem. Tony Soprano, the fictional mafia boss from the HBO television show The Sopranos, was very adept at running fraudulent activities. Imagine this hypothetical scenario. A sustainable fishing company catches a premium batch of fish. They load it onto a smart container and update the digital ledger. A local truck driver, under Tony's control, drives the fish to a warehouse where it is transferred and replaced with fish that looks the same but is spoiled. The spoiled fish is processed in a plant, put into cans, and distributed to a store with the ledger updated at each step along the way. Eventually, a customer buys the fish, eats it, and gets sick. The good news is we can quickly trace the evolution of the fish all the way to where it was caught, which makes the recall quicker and more targeted. Unfortunately, it doesn't account for the fact that the spoiled fish did not come from the fishing company in question. Meanwhile, Tony's guys take the sustainably caught fish and sell it for a premium. This is a textbook supply chain attack, an analog version of the SolarWinds attack. Theoretically, we could solve part of the fish verification problem by taking pictures. However, that poses two crucial issues. The first is scale. There are an estimated 148 million tons of fish consumed every year. Second, and more concerning, is the production gap. With the fish example, we lose provenance in the gap between the product, the fish, and the DLT because it requires a digital device not directly connected to the product itself to capture the relevant information. It is in this gap that Tony's guy can make his move. One could imagine a scenario where a picture of the fish is taken and the packing material is sealed with an IoT sensor that identifies if there is any tampering, temperature fluctuations, or deviations from the trucking route. But that seems ridiculously complicated and expensive. This example demonstrates that no matter how much technology we deploy, we must always account for the human factor. If we are to use DLT or any technology, we must employ it in a way that accentuates its strengths. DLT excels when it is paired with IoT and machine intelligence. Instead of food, imagine a medical device product with IoT sensors in its major component systems. As soon as the device is assembled, every IoT sensor could start to write to the digital ledger. Then that activity is verified via some human and some machine intelligence. In this case, it would be more difficult for Tony's guys to swap out the component parts, which reduces the counterfeiting risk. If we revisit my opening story about the vaccine supply chain, what malfeasance could Tony Soprano have inflicted? This is why we need to take a hacking approach to secure our supply chains. We must think critically about the physical to cyber transition, turning raw materials into manufactured products, or the reverse, cyber to physical, embedding digital solutions into physical products. It is in these choke points that lives are at risk. This is also why we cannot rely solely on digital technologies to secure our supply chains. Digital ledger technology will be part of the bigger solution, but we can't rely on it to be the sole solution. We still need humans in the mix. Specifically, we need human creativity to protect our supply chains because we are matching wits against human creativity, at least until the robot apocalypse. Yesterday's legacy third-party data exchange, the Electronic Data Interchange, EDI. Quote, even though the big ERP system is suboptimal, I chose it because I can sell it internally, unquote. VP of Supply Chain for a CPG company. Created in the 1970s, the de facto standard for data exchange between companies and their suppliers, not even third parties, is Electronic Data Interchange, or EDI. For decades, organizations have relied on EDI to digitize paper invoices and to conduct purchase transactions. The obvious benefits are processing efficiency and the elimination of human labor. Unfortunately, in practice, EDI is expensive, difficult for suppliers to adopt, and isn't terribly fault-tolerant. By design, it's meant to be a hard coding of two organizations' systems. As a result, changes to those underlying systems will break the EDI link. Beyond that, EDI lacks the extensibility required for exchanging information in today's complicated supply chain landscape. Today and tomorrow, we need supply chain systems that facilitate collaboration across multi-enterprise data systems. We need to be able to constantly transfer changing information about invoices, POs, and the like. Plus, we need to be able to extend data models dynamically. Going back to the vaccine example during the pandemic, we suddenly needed to track the environmental controls of vaccines in transit. That is not a use case that EDI readily supports. In a crisis, we need to be able to quickly extend the data models in a way that does not require IT intervention or incur additional transaction fees. Despite the best intentions of EDI designers, what happens is that only top-tier suppliers get onboarded through EDI. The management of EDI orders reverts to spreadsheets and emails, which is self-defeating. Perhaps the biggest challenge to EDI is the cost. Typically, there's a tolling on the transaction, which defeats the purpose of the data exchange. Charging money on data exchange is as old school as is having a CIO. This is the difference between transferring a minimum amount of data for a transaction and truly collaborating with third parties. The need for an ever-growing data exchange is the future of supply chain operations, and a key part of this data collaborative future is deeper integration into core operational systems, whether on the manufacturing floor, warehouse, truck, or customer location. More specifically, we need to build a data exchange platform that's designed for bidirectional data collaboration. Historically, the supply chain is done once the products get to the customer, save for defects and returns. However, the rise of smart products means that they need to constantly phone home. This requires our supply chain infrastructure to consume this reverse data, whether sending updates to the customer product or simply processing information from said device. For example, consider the consumables that come in smart packaging. When the weight of a package hits a certain threshold, a signal could be sent back to auto-order more of the product, or at least notify the planning systems to proactively pre-position inventory. Enabling bidirectional supply chain data exchange with third parties is a use case beyond what any ERP could handle. ERPs have many decades of legacy data models to contend with, but data models will be ever-changing in the bidirectional supply chain. Therefore, we need to start making third-party connections at the cloud layer instead of the ERP. We also have to understand data exchange from the third-party point of view. Hacking tools, 5 takeaways. 1. The ERP is dead. Stop waiting for it to evolve. 2. Embrace the cloud platform as your new supply chain backbone. 3. Design with third-party data exchange at the core. 4. Demand that IT and the CIO earn their participation. 5. Make sure your digital transformation is not an ERP upgrade in disguise. Bonus: keep Tony Soprano out of your supply chain.